Hello Flight Simmers and welcome back to Alpha Hotel Flight Simulator Training. This video is part 1 of a multi-part series on learning how to fly GPS approaches, formerly known as RNAV GPS approaches. In this video, we'll be discussing the basics of RNAV GPS approaches, how they work, and how to fly them. In the videos that follow, we'll take to the air to demonstrate how to fly some of the various different types of RNAV GPS approaches with various GPS receivers, such as the G1000 and the GNS 530. Before we begin this video, I'll mention that it is a good idea to have a basic working knowledge of the fundamentals of instrument flight, as well as the fundamentals of how instrument approaches work. It's also a good idea to be familiar with procedure turns and holding patterns, as they're often incorporated into RNAV GPS approaches. If you're not familiar with those concepts, I'll leave a link to my videos on those topics in this video's description. So what is an RNAV GPS approach? An RNAV GPS approach is an instrument approach procedure that's designed to be flown using a GPS receiver and that does not rely on ground-based nav aids for the procedure to be operational or to be flown. RNAV GPS approaches are probably the most common type of instrument approach in the world these days. They allow precise approach procedures with relatively low minimums to be designed for almost any airport of any size, and don't require the airport to install or be in close proximity to expensive ground-based equipment in order to have an instrument approach procedure. Since they're not dependent on ground-based nav aids, they can be tailored for a specific airport or runway and the surrounding terrain and airspace. They can also be designed for just about any runway so long as the terrain and airspace allows for an instrument approach. So most airports that have an instrument approach procedure will have an RNAV GPS approach, and many IFR airports will have this type of approach for every runway on the field. In theory, RNAV approaches are some of the easiest approaches to fly. As long as you load the approach correctly, you just basically follow the GPS course guidance to the runway. But there are some specific requirements that must be met for these approaches to be flown legally, different types of approaches with different minimums, and many different GPS receivers that display data about these approaches in different ways. So it's important to be aware of those differences and know how the receiver you're using works and displays information as you fly the approach. So let's take a look at how RNAV GPS approaches are designed. First off, there are two basic types of RNAV approaches you can find. The most common type is the one labeled RNAV (GPS). These are basic RNAV GPS approaches that are available for all pilots to utilize. The second type are the approaches labeled RNAV (RNP). You'll notice that these approaches all have the remark "authorization required" near the bottom of the plate. It's also not uncommon for these approaches to have curved paths on their initial or intermediate segments, and that's sometimes another way you can tell that you're looking at one of these. In the real world, you need special training and authorization from the FAA to fly these type of approaches, so they're usually only flown by airline and corporate flight departments. In most cases, these approaches are not available in the database of GA GPS receivers and cannot be flown by general aviation pilots. Most of these approaches are not available in the GA GPS receivers in Microsoft Flight Simulator either, but that being said, if you do find one in your database, you can fly them in Microsoft Flight Simulator. Any receiver capable of flying advanced RNAV approaches is capable of accurately flying the RNP approaches as well. And the technique for flying them is really not that different than the technique for flying a normal RNAV GPS approach. Just be aware that in the real world, you can't fly them without specific authorization to do so, and again, you won't be able to find most of these approaches in the database of a GA GPS receiver. So let's take a look at how a basic RNAV GPS approach is designed. Most approaches are designed as straight-in approaches, since they don't rely on ground-based nav aids to determine where their course is located. Like most straight-in approaches, a GPS approach will have a final approach segment that's about 5 miles long, terminating at the approach end of the runway and aligned with that runway. Like the final approach segment of any instrument approach, this is a segment on which the pilot will make the descent towards the runway for a landing. They also typically have an intermediate segment preceding the final approach segment. This segment is also usually about 5 miles long and also aligned with the runway. Aircraft approaching the airport anywhere within 90 degrees of the intermediate fix can navigate directly to this fix and then in on the approach without having to perform a procedure turn. Many RNAV GPS approaches are designed with initial approach fixes about 5 miles from and 90 degrees to either side of the intermediate approach fix, creating a T-shaped approach design. This design allows aircraft approaching the airport from either side of the airport and downwind of the intermediate fix to navigate to one of these initial approach fixes, then to the intermediate approach fix and in on the approach without having to perform a procedure turn. These approaches do typically include a holding pattern in lieu of a procedure turn at the intermediate approach fix should a pilot wish to utilize it. This makes this fix double as an initial approach fix when you pass over it the first time on your procedure turn outbound, and an intermediate approach fix when you pass over it the second time on your way to the runway, which is why it's labeled IF/IAF. There are also approaches that are designed in a similar manner to the T-shaped approaches, but are not exactly the same, with initial approach fixes or feeder fixes placed in a slightly different location based on the local airspace. With these types of approaches, it's important to read all the notes on the chart to make sure you understand and comply with any limitations and instructions on the procedure. Another common approach design is to omit the two outboard initial approach fixes and just have the intermediate fix pull double duty as an initial approach fix with a holding pattern in lieu of a procedure turn and an intermediate fix. With this design, aircraft approaching from the upwind side of the intermediate fix can still navigate to this fix and in on the approach, but anyone approaching from the downwind side of the fix will be stuck doing a turn in that holding pattern procedure turn to get established on the approach. This type of approach is more common at smaller airports and approaches to shorter runways. There are some RNAV GPS approaches that are tailored specifically for the terrain or airspace of the local area. In these cases, the same rules apply that apply to any instrument approach. You'll need to take a look at the feeder fixes and initial approach fixes and see what works best for the direction you're approaching from. Then make sure to carefully read all the notes and altitudes before you navigate onto the approach. There are also some airports where terrain or other local factors prevent the utilization of a straight-in approach, so circling RNAV GPS approaches are utilized in these circumstances. Another feature you'll find on many RNAV GPS approaches that is uncommon on other types of approaches is the use of terminal arrival areas or TAAs. TAAs take the place of minimum safe altitudes or MSAs. To review, MSAs are shown in a circle with the letters MSA above the circle, as well as a fix or nav aid, and the distance from that fix or nav aid that the MSA covers. MSAs are advisory altitudes that tell the pilots the lowest altitude they could fly and still have legal instrument obstacle clearance in the area depicted. But they are not procedure altitudes, meaning they are typically for emergency reference only. In non-emergency circumstances, you would need clearance from ATC to descend to these altitudes in the real world. You can tell if you have a TAA instead of an MSA if the circle is divided into several different segments and the segments are moved to different parts of the plan view. Unlike MSAs, TAAs are procedure altitudes, meaning that if you have clearance for the approach on which they're depicted and you're within the area depicted, you may descend to that altitude without additional clearance from ATC. So to take a look at an example of what a terminal arrival area is and how we would use it, let's take a look at this approach, the RNAV GPS to runway 7 into Russellville Regional. The identifier on that airport is Kilo Romeo Uniform Echo, and it's located in Russellville, Arkansas. So we can see when we look on the approach, we do, instead of having an MSA circle, we have the circle divided into 3 different segments, which tells us that we have a terminal arrival area, or TAA. Each of these sectors is based on one of the fixes from which we can start the approach. So the Big 180-degree segment over here is based, if we're coming in from the west, is based on PAB, which is the intermediate approach fix coming in from the west over here. The segment down here to the southeast is based on AVO, which is the initial approach fix if we are approaching from the southeast. And then the segment up here to the northeast is based on URI, which is the initial approach fix you would use if you're approaching from the northeast. So how this would work, let's assume that we are approaching from this direction, from roughly the west southwest, and we are cruising at an IFR altitude of 5,000 feet for our eastbound flight. And we are within 28 nautical miles. We've been cleared direct to PAB, and we are 28 nautical miles from PAB. So approach or center calls up and says, you are cleared for the RNAV GPS to runway 7. That automatically authorizes us to use these procedure altitudes. So since we're within 30 nautical miles, we look at the terminal arrival area. It says 4,300 feet. We can go ahead and descend from 5,000 feet down to 4,300 feet. Once we get within 8 nautical miles, then we see this intersector here allows us to go down to 3,500 feet. So at that point, we can go ahead and go down to 3,500 feet. You'll also see on this sector that it notes no PT, so we do not need to do the procedure turn, the holding pattern in lieu of the procedure turn when we are approaching from this direction in this sector. So we don't need to do that. And then once we are down at 3,500 feet, we go ahead and go to the plan view and start utilizing the altitudes that we see here on the plan view. So that's how that would work if we're approaching from the southeast. The same sort of thing is true if we're approaching from the southwest. If we're approaching from the southeast and then we've been cleared direct to AVO, we'll assume we're up at 6,000. We'll assume we get to 30 nautical miles out and they clear us for the approach. Then we can go ahead and descend from 6,000 down to 3,500 feet because it is a procedure altitude. Once we hit AVO, we'll proceed in to PAB from there. It says 3,500 feet on this segment and no procedure turn, so we don't need to worry about this procedure turn. And then we can fly in on the approach from there, utilizing the altitudes on the plan view again. So that's kind of a basic overview of how terminal arrival area altitudes work. Now let's talk about the different types of lateral and vertical guidance you can get on these approaches. When looking at the minimums of an RNAV GPS approach, you'll see a lot more lines than you'd see on an approach with ground-based nav aids. You'll see things like LP+V, LNAV, VNAV, and LNAV. So what does all this mean? These are references to the different kinds of lateral and vertical guidance you can utilize on the approach, with each different type of guidance having different minimums. Let's take a look at the types of lateral guidance we can utilize first. There are two types of lateral navigation we can get on an RNAV GPS approach: LNAV, or basic lateral navigation, and LP, or localizer performance. LNAV is the basic type of lateral navigation that all IFR certified GPS receivers are capable of on GPS approaches, and was the type of guidance available to pilots when GPS approaches first came into use. With this type of guidance, the course width, or CDI sensitivity, is 0.3 nautical miles full-scale deflection to full-scale deflection at the final approach fix, and is a constant width. In other words, it stays at that width from the final approach fix to the missed approach point, which is usually the runway threshold on GPS approaches. The second kind of lateral guidance is LP, which stands for localizer performance. With this type of lateral guidance, the CDI sensitivity is 0.3 nautical miles side to side at the final approach fix, just like an LNAV approach, but it narrows as you fly towards the runway so that the course is only 700 feet wide side to side at the runway threshold. This mimics the increase in sensitivity and narrowing of the course you find when using an ILS localizer, hence the term localizer performance. LP approaches are only available on SBAS-equipped GPS receivers. SBAS stands for Satellite-Based Augmentation System and is a system that uses a network of ground-based stations to improve the accuracy and reliability of GPS information by correcting satellite signal measurement errors and providing information about the accuracy, integrity, continuity, and availability of its signals. Different regions of the world have different names for their SBAS systems, such as WAAS in the United States and EGNOS in Europe. So an SBAS capable system has better precision accuracy than a non-SBAS system, and that allows it to fly advanced and highly accurate RNAV approaches like LP approaches, as well as RNAV approaches with vertical guidance that non-SBAS receivers could not. And we'll talk about which receivers in Microsoft Flight Simulator are SBAS capable here in a little bit. Now let's look at the types of vertical navigation or vertical guidance we can utilize. There are three types of vertical navigation that you can have on an RNAV GPS approach: approved vertical navigation, no vertical guidance, and advisory vertical guidance. It's worth noting that you need an SBAS capable receiver or barrel compensated system to have any system generated vertical guidance. Receivers without these systems are not capable of generating any sort of glide path or vertical guidance for you to follow. And again, we'll talk about which receivers in Microsoft Flight Simulator are capable of this in a bit. With approved vertical navigation, the GPS generates a glide path that can be flown to a decision altitude, similar to the way an ILS is flown. This can only be utilized on SBAS capable receivers. If you have a receiver that is LNAV only, it will not be able to generate a glide path that you can follow. When you combine approved vertical navigation with LP lateral guidance, you get an LP+V approach, which stands for Localizer Performance with Vertical Navigation. These approaches are flown basically like an ILS. You follow the lateral guidance provided by the GPS and fly the glide path that's generated by the GPS, very much like you would fly an ILS approach. You fly this down to a decision altitude where you either acquire the runway and proceed to a visual landing or miss the approach. As far as the autopilot goes, you can arm and activate the nav function on the autopilot or flight director to capture or track the lateral guidance generated by the GPS, and you can arm or activate the approach function on the autopilot or flight director to capture and track both the lateral function and the vertical guidance or the glide path generated by the GPS. When you combine approved vertical navigation with LNAV lateral guidance, you get an LNAV/VNAV approach, sometimes referred to as an L/VNAV approach. Like the LP+V approach, this is flown basically like an ILS approach in that you follow the lateral and vertical guidance from the GPS down to a decision altitude where you either proceed to a landing or execute the missed approach. The only difference is that the lateral course width will not decrease as you get closer to the runway. It will stay the same width. Just like the LP+V approach, you can arm or activate the nav function on your autopilot or flight director to capture and or track the lateral course guidance from the GPS, and you can arm or activate the approach function on the autopilot or flight director to capture and track both the lateral and vertical guidance from the GPS. Although RNAV GPS approaches with vertical guidance are flown in a similar manner to precision approaches, they are not considered precision approaches by the FAA. The FAA classifies these approaches as approaches with vertical guidance, or APVs, but for things like alternate planning, they are still considered non-precision approaches. Sometimes vertical guidance is not available on GPS approaches. This can be due to a number of reasons. The first is that the approach simply does not offer vertical guidance. Some approaches are designed without vertical guidance, and they are designed that way on purpose because of terrain or other factors in the area. So that could be the reason you're not getting vertical guidance on a certain type of approach. Your GPS receiver is not SBAS capable or barrel compensated. And again, we need one of these two types of systems to be able to generate that vertical guidance. So if your receiver is not capable of those modes, then it will not offer vertical guidance. And then the last one is that the SBAS or barrel compensation function of your GPS receiver is inoperative. And there could be a number of different reasons that this happens. It could be that there is a malfunction with your GPS, which you shouldn't see in Flight Simulator. It could be that there is a outage in the SBAS network that you're using, like the WAAS system in the United States. Sometimes there are regional outages. Something like a ground station going out can prevent this function from working. And then the receivers also, on some of the receivers, even in Microsoft Flight Simulator, you have the option of turning these functions off. For instance, on the GNS 530 and 430, you can actually go into one of the menu options and turn the WAAS system or the EGNOS system off, so it becomes an old-fashioned LNAV receiver without vertical guidance. So if you want to try flying those types of approaches with that receiver, you can do that. So there are still approaches that you can shoot when you don't have vertical guidance. The two different types of approaches you can have, or if you have LNAV lateral guidance and no vertical guidance, you have an old-fashioned LNAV GPS approach. And if that's what the minimums look like, and that's what that line of minimums is for. And then if you have LP lateral guidance, but no vertical guidance, then you have an LP approach, and that's what the minimums look like there. And there are specific approaches that are designed to be LP approaches. They're fairly rare, but there are some airports around the country where you can find these, where they have LP minimums but not LP+V minimums. Both of these approaches are shot like a localizer approach in that you are going to follow the course guidance from the GPS, and you're going to descend to a minimum descent altitude rather than a decision altitude. And then you're responsible for your own vertical navigation. You decide whether you want to do the dive and drive type descent and descend from your last platform altitude down to the MDA and then fly forward to your missed approach point. Or you can do that continuous descent and final approach technique where you calculate your descent rate, and then use a derived decision altitude to execute your missed approach at. If you're using an autopilot or a flight director with both of these types of approaches, I'll mention the only difference between these types of approaches is that the LNAV approach has a course that does not get narrower. It stays at 0.3 nautical miles from the final approach fix all the way to the missed approach point. And then that LP is a lot like the LP+V, except it doesn't have vertical guidance, and it narrows from 0.3 nautical miles at the final approach fix down to 700 feet at the missed approach point at the runway threshold. And when you're using an autopilot or flight director with both of these type approaches, you can use the nav mode to capture or track the lateral course guidance. But to descend on these types of approach, you're going to need to use a vertical mode such as vertical speed or IAS or flight level change to control your vertical path. Finally, many SBAS capable GPS receivers will have a function that provides advisory vertical guidance in the form of a GPS generated glide path that is advisory in nature. This may be available on approaches that don't have approved vertical navigation, such as LNAV approaches or LP approaches, if your receiver is SBAS capable. And I believe this also works for barrel compensated systems as well. These are not approach types recognized by the FAA, so no minimums for these types of approaches are published. You need to use the minimums for the appropriate approach without vertical navigation, such as an LNAV or an LP approach. The two different types of approaches you can have when you're using advisory vertical guidance is the LP lateral guidance plus the advisory vertical guidance. This creates an LP+V approach. And then an LNAV lateral guidance plus advisory vertical guidance equals an LNAV+V approach. So looking at an example of how this works, let's take a look at the RNAV GPS approach to runway 27 at Stuttgart Municipal in Stuttgart, Arkansas. The identifier on that field is Kilo Sierra Golf Tango. If we take a look at the approach minimums, you'll notice that we have only LNAV minimums for this approach. So it is an approach that does not have any sort of vertical guidance built into the approach. But if we pull up this approach on a SBAS equipped receiver such as the G1000, you notice that It does contain advisory vertical guidance, so we can actually get a glide slope. It's just advisory in nature. So we go to pull it up in the GPS database. We have this LNAV+V approach, but there are no minimums for an LNAV+V approach, so we still have to use the LNAV minimums and the LNAV MDA. We could treat that as a DDA at 50 feet and use it as a decision height if we wanted to do that, but it does not have any sort of vertical guidance minimums. We have to use the non-vertical guidance minimums that are on the chart, but we can load it up in the GPS and get a glide path. Now let's talk a little bit about GPS receivers. In order to fly an RNAV GPS approach, you need to have an IFR certified GPS receiver in the airplane. Generally, to be IFR certified in real life, the GPS receiver has to be something that's installed in the aircraft's panel. Portable or handheld GPS receivers generally can't be used for IFR operations. The receiver also needs to be able to display course information on a primary flight instrument like an HSI or CDI. Referencing the moving map as your only source of course information is not acceptable. The moving map should only be used for situational awareness. The receiver should also be capable of alerting a pilot when the GPS integrity has been compromised, and most will have an indication that displays when the receiver is in the approach mode. So which receivers in Microsoft Flight Simulator are IFR certified and can be used for RNAV GPS approaches? The most prolific is the Garmin G1000 NXI, which, with the working title upgrade, is fully IFR and SBAS capable and can fly just about any real-world IFR GPS procedure. It's available in a number of aircraft in Microsoft Flight Simulator, both default and third-party. Its close relations, the Garmin G950, the Garmin G3000, and the Garmin G5000, are also fully IFR certified and SBAS capable in Microsoft Flight Simulator. The Garmin GNS 530 and 430 are also both fully IFR certified and have been upgraded by working title to be SBAS capable and are able to fly any real-world IFR GPS procedures as well. Any default aircraft that has a customs avionics suite that includes an FMS with GPS is also generally capable of flying RNAV GPS approaches. Avionics suites that have been upgraded by working titles should be SBAS capable and work quite well. At the time this video is recorded, that includes the Cessna Citation CJ4, the Boeing 747, as well as the Boeing 787 from the Premium Deluxe Edition. Many third-party aircraft are also either using the working title nav system or have their own proprietary FMS nav systems with GPS that are also capable of flying RNAV procedures. But anything that has not received a working title upgrade may still be using the default SOBO navigation system, meaning while they may be capable of flying RNAV GPS approaches, things like procedure turns and missed approach procedures may not be available in these aircraft, and the default system can be quite quirky in both loading and flying procedures. For PC users, there are two third-party units that are fully IFR capable as well. The first is the PMS-50 Garmin GTN 750. This unit is primarily used in third-party aircraft, though it can also be used as a replacement for the G1000 in any default aircraft so equipped. If you want to see what aircraft it's compatible with, just visit their website and browse through the list of compatible aircraft. There's a free version and a payware version available, but both versions are fully IFR certified and capable of all the features that allow for the flying of advanced RNAV GPS approaches. The second is the TDS Garmin GTN 650 and 750 NXI. This is a payware product that is the next generation of the Garmin GTN 750 and 650 receivers, and they're also fully IFR certified and SBAS capable. Like the PMS-50 GTN, the TDS units are mostly for use in third-party aircraft. So with both of these units, make sure to check their aircraft list to see if they can be used in any of the aircraft you own. The other two default units in Microsoft Flight Simulator, the Garmin G3X and the Garmin Era 796, are not IFR certified receivers in the real world, and most of the aircraft they're installed in Flight Sim are not IFR certified either. That being said, their database does have all of the IFR procedures, including RNAV GPS approaches. So if you want to try flying these approaches with these receivers, you can certainly make an attempt in the sim. Just be aware that they're both still using the default Asobo nav system. So again, things like procedure turns and missed approach procedures won't be available, and the system is still quite quirky. So loading procedures will not always work correctly, and they won't always execute the procedures correctly either. If I missed any receivers that you know are capable of flying RNAV GPS approaches in the sim, let me know in the comments section. So before we finish up, let's take a look at how to load a GPS approach. We'll do a demonstration here in the G1000. We're actually going to do a separate set of videos where we go out and fly different types of GPS approach procedures using different GPS receivers, but this will give you a broad overview of how to load up an approach. The technique is very much similar between the different Garmin units, so if you can load it on the G1000, you can usually figure it out on those other units. But again, we'll be doing a separate set of videos to get into the details of how to operate those receivers and how to fly specific different types of approaches in different types of receivers. So the first thing we want to do is hit our procedure key, or on other GPS receivers it'll be in the menu somewhere to find the procedures button. So we hit that. We want to select approach, then we'll hit enter. If I had a flight plan loaded, my destination airport would most likely be pre-populated here, but I don't, so I will just have to enter an airport here. I'm going to load the RNAV GPS to runway 36 in Stuttgart. Identifier for that airport is Kilo Sierra Golf Tango. Golf Tango, there we go. Stuttgart, Arkansas, Stuttgart Municipal is what I want. So I'll hit enter, and then it goes down to the approach field. I use the large knob to scroll down to the approach that I want. You can see I've got the RNAV GPS runway 9. That's an LNAV plus advisory vertical guidance. I have an RNAV GPS to runway 16, which is an LP+V approach. I have an RNAV GPS to runway 27, which is again an LNAV with advisory vertical guidance. And then I have the RNAV GPS to runway 36. And you can see it shows the approach up there as I'm scrolling through the options on the G1000. So I'll go ahead and hit enter, and then it asks me transition. Where do you want to start this approach from? So since we're coming down from the the southeast from the Pine Bluff area, I'm going to navigate to that initial approach fix, actually the intermediate approach fix of Hogum. So I'll go ahead and select that. You can see here it tells me this is the initial approach fix, and it shows me it's going to load the procedure turn, which I don't want to fly. I just want to fly straight on in. So we can go through and edit that here in just a second, but for the moment, that's what I'm going to select. So I'll hit enter. It says, well, actually gives you the option to whether or not you want to fly the course reversal. I do not. So I will go ahead and hit no, and that will take me straight on in. I do have the option to set the minimums here. I do recommend if you're loading an approach, go ahead and set the minimums. Why not? So we would normally do that. And once you have your minimum set, then you would go down, scroll down to activate, and go ahead and hit activate. Sometimes you'll have the choice between load and activate, and the difference between those two is load will put the approach and all the approach waypoints at the end of your current flight plan. So if you want to go ahead and have the approach in there, if you know what approach you're going to be shooting and you want to have it at the end of your flight plan, you can hit load. Activate will take you direct to the first point on the approach. So in this case, it would take us direct to Hogum. We don't have any other flight plans in here, so I'll go ahead and activate by hitting the enter key, and now you can see it is all loaded up here. I can hit the flight plan key here, and it'll take it away. And you can actually see on the map it's got me going to Hogum and then going on in on the approach from there. Once you've loaded the approach, it's just a matter of following the lateral guidance and either following the vertical guidance or descending as appropriate on the approach. In the next several videos, we'll again be taking to the air and demonstrating the various different types of RNAV GPS approach procedures on some of the different GPS receivers you can use in the sim. We'll talk about how to load them, how to fly them, and some of the particular techniques that you'll want to use for each specific type of approach and for the specific type of receiver. So make sure to tune in for those videos. That finishes up this video. As always, if you've enjoyed the content, don't forget to like the video, subscribe to the channel, ring the notification bell to be alerted to new content, and share with your friends. Thanks for watching, and we'll see you next time.